The purpose of these videos is to go through the actual answer key here and just try to help you talking through some of the solutions here. So one of the main things with polar coordinates is to realize that there are a lot of different ways of expressing the same point. So this point here has an r value of -3 and a theta of 5 pi over 3. So the first thing we got to do is realize that if we go around here to 5 pi over 3, we would plot a positive r value along here. Well, since we have a negative r value, we go in the opposite direction, and that is a distance of 3. So that's how we get to point P right here. Well, that's not the only way to describe that point. We could talk about different restrictions. There's an infinite ways to name point P, but what we're doing in these problems is giving you the restrictions. So you have to have theta 2 pi over 3 in this case, which is the one on the opposite side here. It's actually this, whoops, I had the wrong thing there. That was kind of cool. This angle right here is 2 pi over 3, but since we need to keep P over here, we have a positive 3. So I do have what they told me here, and I do have a theta in between there. So I'm following the restrictions. Well, now they're saying R has to be less than 0. Well, in that case, I need to be talking about, getting to here somehow. Well, now theta has to be between -2 pi and 0. So that's going to bring me down here to -pi over 3. But then again, to get to this side, I have to have a negative r. So you're just following along, trying to get it. I'll leave the next one for you to explore, but that's the concept on that. All right, and then another huge part about this assessment coming up is that you will have to go from rectangular to polar and polar to rectangular. Well, obviously here we were given polar coordinates. So if you look at the, if you simply look at this little picture here, this diagram, it has 7 pi over 4 drawn here, and that leaves us with a 45-degree reference angle, or pi over 4. So 1 root 2. And now it's pretty straightforward because I have this information to find cosine of theta. So I know that cosine of theta is going to be adjacent over hypotenuse, so I just follow the very straightforward formula that x equals r cosine theta. So there's my cosine theta coming straight from this diagram, and then this is my r that came from the ordered pair. So if I just follow the formula, I get my x coordinate. Same thing down here. Y is equal to r sine theta. You should be seeing that all over your notes. And then sine theta is -1 over root 2, opposite over hypotenuse, times this -5. And we have an ordered pair here. Don't worry about rationalizing them, but we have an ordered pair that's left, right? That is left, and then is up. So actually the ordered pair is left and up, which is up here, which makes sense because if you were to follow this actual ordered pair in polar coordinates, you would go all the way like we did here, but then you'd have a negative r value, so we would be on the other side. So it's very important that you see that those connect, and then you'll get the problems correct. All right, a little different procedure on this one would be finding a set of the finding the polar coordinates from rectangular. So if you look at this right here, and I drew just the reference triangle here, but this means we're going to go right 7, and we're going to go down -7 root 3. Well, that's a 1 root 3, 2, and we have this reference triangle right there. So it's very straightforward, x squared plus y squared equals r squared, to come up with the value of r here. The other thing you could do is just think about the relationship of 7 root 3, and 14 in that 30, 60, 90 triangle. Long story short, your r value is going to come out to 14. Now, what could we do? Well, we just got to make sure that we're going in that direction. So if I actually use this one right here, I am going to go -pi over 3, and then I'm going to have a positive 14 along there. This is just a reference triangle. I could have, if I wanted to, I could have started here and gone over here. Well, what would that extend out? It would be a different theta, right? but then I would have to use a negative 14. So there are, again, an infinite amount of ways when we don't restrict where your answers have to be, but they will all have an R value of 14 or negative 14. This one can be a little tricky here. First things first, I just want you to make sure you see how we draw our picture here. I don't know if I zoom in, this will be too much here. Whoops. Let me do this real quick. I just want you to see this a little more closely. So left 2, up 3. Pythagorean theorem will give you root 13. So that's basically what I'm doing right here. We know that R values can be plus or minus root 13, depending on how we're using, that or the situation. Okay, so what am I doing right here? If you look here, I have to, in order to find polar coordinates from rectangular coordinates, there's only 2 things I need. I need the R, which I have, and I need theta. Well, in this scenario, I don't have a nice special right triangle to just tell you guys what theta is, so I'm going to use tangent. And tangent of theta is equal to 3 over negative 2, which I have here. And then we use the arctan in order to actually solve this theta value. Now, you are going to want to put your calculator in radians. And when you do that, you get theta coming out to approximately negative 0.983 here. So now what does that mean? Well, again, just so we clearly understand, that is this little reference angle, correct? So we got negative 0.983 because of this situation. Tangent would be negative here, right? So what do we have here is, looking over here, trying to get you to understand how we get that. If you take this value right here away from pi, because watch, this would be pi all the way to there, right? If we took pi minus that, we would get 2.159. Now, this theta is coming out to a negative here. I believe that should have been a, whoa, what was that? That should have been a positive there. If you give me a, yeah, so this one should have been a positive right there because pi minus, yeah, that would be 2.159. So I don't know what I did there in my work, but this will come out to a positive 0.983. And then where do I get the 2.159? Once again, there are multiple ways. You need to understand to actually name the coordinates for this point. One way would be to go all the way to here. Well, this is 3.14. If I subtract this angle, I will get that it's kind of off the screen right now, but I will get the 2.159 there. Okay? Now, why is the root 13 positive? Because that's the rotated axis. That's the angle I went to, so I want to go along that by the length of R there. Alrighty. Zoom out a little bit for this one. Okay, down here, this was a little goofy one just because the pi's in there, but it's no big deal. Basically, when I have R equals something, I know, when we started this one with just R equals pi. Well, pi is not a variable, right? It's just, if we were to abbreviate, 3.14, so it's going to have a radius of pi. So we're going to get a circle here centered at the origin with a radius of pi, and this would be the standard form of that. And I think if you just connect those two ideas, you can see that. Obviously, mathematically, you could square both sides and replace R squared for that conversion into into rectangular from polar. Again, this one right here, you can, a lot of your instincts are always to multiply by R right away, but I would hope that wouldn't be. I hope you see that this right here is really 1 over cosine. So secant turns into, 1, so negative 6 times 1 over cosine is just negative 6 over cosine. And then I'm going to multiply both sides by cosine. And the purpose of doing that is that now, what do I have on the left? I have R cosine theta. The only thing that's left here is negative 6. R cosine theta is simply x. So that was a simple vertical line going through that procedure. Okay, and then let's, I think I'm going to cut this first video off at the front page of day 4 so you can look through here. But pretty basic, straightforward example is 6a. 6b is a little trickier. But I'm giving you rectangular equation. We all hopefully know that this would have a negative slope, -1. The y-intercept is 0, so that's all this is showing you there. I do know that if I rise 1, run 1 that way, that's going to leave a 45-degree angle right there. So what does that mean? Well, that means that in radians, I could go 3 pi over 4 that way, and there is no restriction on my r. My r is going to be positive, my r is going to be negative, so that's why we can simply write it in polar coordinates, a line like that, an oblique line with a y-intercept of 0 by just saying what theta is equal to. Now you can see I have a second answer here because it's definitely possible. You could go and you could go down negative pi over 4, and that will give you the exact same line because there's no restriction on the r there. By the same token, there's many more answers because we could go all the way around to 7 pi over 4 and we could have an answer there as well. So many different ways to get the answer, but realize you're just connecting the rectangular coordinates to the polar coordinates. Okay, let's understand on this one. I think this is done in 2 parts. So I want you to see what I'm doing here first. Again, they have asked me to sketch a graph represented by both equations. It's going to be the same graph. Don't think there's 2 graphs. If there's 2 graphs, you're not grasping the concept. The concept is they're going to give you the same outcome, just in different ways. So no graphing calculator, that's fine. But this first journey right here is simply taking in rectangular coordinates, getting the negative 2y over to this side, subtracting the 8x, and completing the square 2 times. So I got this all equal to 0. I completed the square 2 times. I have a 17 on this side. And what I have right here is my understanding of a circle with a center at 4, -1, and a radius of the square root of 17. Okay, so this is just a quick little sketch. The square root of 17 is obviously a little bigger than the square root of 16, so it's 4 point something. So that just gives me a sketch and an idea of what this is, because that's what they wanted me to do. Well, the second part is up here, and I'll highlight this in blue, is I got to convert it into its corresponding polar equation. So I want you to know I'm not going from here right now into this work. What I'm doing is something different. I'm recognizing that x squared plus y squared is equal to r squared, straight up substitution there. What's x equivalent to? R cosine theta. And what's y equivalent to? R sine theta. So to see what I'm doing from here to here is substituting from rectangular into polar coordinates. All right? Well, then it's a little tricky. Try to follow the math there, but I mean, it's not really that tricky. It's just basic algebra. If we subtract 8r cosine from theta from this side, add 2r sine theta to this side, this is what we're left with. And if you notice, there's an r, so you can either divide everything by an r or factor out an r, which basically gets us to a situation where we don't need, and then we're left with this. Well, again, the zero product property says, hey, r could be 0, or if we went and took this off and set it equal to 0, we would have to get everything over to the right side again, but we would have r by itself. So getting r by itself is how we finish getting into the polar coordinates.